Hello, thank you for checking out A1 Math, and today we're looking at constructing arithmetic sequences. And what I want to do first is go over some of the notations for writing an arithmetic sequence and some of the rules here. So in my previous videos, I talked about how you have the recursive rule and the explicit rule, and I didn't really talk about the name of the notation, but we use subscript notation, okay? And with the recursive rule, we have ace of one and ace of n, and that a sub is referring to the subscript on how you write the n or n minus one below, or ace of one below the a. Okay, and today we'll work with function notation. And with function notation, it's exactly the same thing. It's just written a little differently. So instead of having subscript, it has function notation where you have uses something similar to f of n or f of x, but um, instead of having f of x, we're going to use f of n. So we have f of 1 that's referring to your first term, and f of n is referring to whichever number of the term you plug in. Same thing as the subscript notation. So I want to be clear and show you what that was before I go into writing with function notation. But let's take a look at constructing arithmetic sequences. Okay, for our first example, we're looking at constructing an arithmetic sequence, and it says here the table shows the number of plates left at a buffet after n hours. It says write the recursive rule and the explicit rule for the arithmetic sequence represented by the table. So instead of just having a list of numbers, it gives us an actual table that we're working with. All right, so we've got our numbers here, and it's saying the first term is 155, the second term is 141, third term is 127, and so on. So what we want to do is find our first term, which we know what it is. It is 155, and we want to find the common difference. Those are the two things we need to do. Need to write both rules, the recursive and explicit. All right, so when we're writing to get the common difference, what we want to do is take the second term and subtract it from the first term. So we'll take 141 and subtract it from 155. So when we do that, we get negative 14. So our common difference is negative 14. Okay, now we already know that first term, and we're going to use function notation here. So we'll have f of 1 is equal to 155. All right, so first I'm gonna write the recursive rule. That's the easiest one. So the first thing you gotta do is write the first term. F of 1 is equal to 155. And then write f of n is equal to f of n minus 1 minus the common difference, which is 14. And that's the recursive rule. Okay, now I'm gonna go ahead and write out the explicit rule. So we already have the common difference. We already have the first term. So I'm gonna go ahead and write out the explicit rule, which would be f of n is equal to your first term, which is 155, minus the common difference, which is 14, times n minus 1. And that is the explicit rule. And that's it. So here we don't have to figure out the term or anything. We just need to be able to write the recursive rule and the explicit rule. Okay, let's take a look at another example. Okay, so we're going to take the common difference. We're going to take the second term and subtract it from the first term. So we're going to have 16 minus 6. And that's going to get us 10. So a common difference is 10. And then our first term, which is given, f of 1 is equal to 6. Okay, now we have everything we need to write both the recursive rule and the explicit rule. So I'm going to start with the recursive rule. So that's going to be, first we list the first term, which is 6. F of 1 is equal to 6. And then we write the rule. We're going to say f of n is equal to f of n minus 1, which only represents the previous term, plus the common difference, which in this case is 6. And that's the recursive rule. All right, now I'm going to write the explicit rule. So we're going to start off with f of n, and then we write in our first term, which is 10. And then we go ahead and add that common difference, which in this case is 10. I'm sorry, 6. Times n minus 1. Let me fix that. Our first term is 6. And our common difference is 10. And we're going to multiply that times n minus 1. And that's our explicit rule. All right, now let's take a look at one more example. Okay, here it says Jerry collects hats. The total number of hats in Jerry's collection depends on how many years he has been collecting hats. After the first year, Jerry had 10 hats. Each year, he added the same number of hats to his collection. The graph shows the sequence. It says write the explicit rule and function notation for the arithmetic sequence. So on this one, we just need to write the explicit rule. But they give us the chart of the hats being collected. So what I'm going to do is go ahead and make a table. Okay, and with this table, I'm going to go ahead and say n and f of n. And the n is going to represent the number of years, and f of n is going to represent the number of hats. So after 1 year, he has 10 hats, 2 year, 18 hats, 3 years, 26 hats, and 4 years, 34 hats. So now I've got the secrets 10, 18, 26, and 34. So the two things we need is the common difference and the first term. So let's start with the first term. So the first term, f of 1, It's going to be 10 because that's our first term. Next, we're going to find a common difference where you could take the second term, in this case 18, and subtract it from the first term, 10. And since it is the same number of heads, that's automatically lets you know it's going to be an arithmetic sequence. So you got 18 minus 10, which is equal to 8. All right, now, so we've got a common difference, which is 8, and we got our first term. So I'm going to start off by saying f of n is equal to our first term, which is 10, minus the common difference, or plus the common difference, which is 8, times n minus 1. And if you want to know how many hets he collected after so many years, you just plug that number in for n and go ahead and solve. But for now, that is constructed arithmetic sequence. I want to thank you for checking out A1 Math. Have a nice day.